My name is Jeff Krause. I have a PhD in chemistry from Queen's, and I am currently employed at the University of Waterloo. Today I'm just going to go through a couple undergraduate level chemistry topics just for my first session here. So the first of these is just to discuss the density of water. The question is just density of water, but I'm going to follow along similarly to the answer given, which just discusses why it is that the density of water tends to peak at around 4 degrees. So density, just to start off, is an average quantity over a volume. So what we're talking about is an amount of mass divided by some volume, right? So water looks like this, and of course what it wants to do is hydrogen bond to other water molecules and kind of fit into this ice shape that some of us might be familiar with. But at the same time, everything is moving around, so that would be temperature, right? So our density, which would be kind of computed by calculating the amount of mass in some volume, it comes out to be some quantity, but then temperature is making everything move and jumble around as according to whatever that is, right? So temperature is related to its average kinetic energy, or how fast it's moving around. And so although the intermolecular forces want to pull it into some crystalline shape, it can't quite get into there, because also there's interactions between oxygen atoms, which are repelling each other, and other hydrogen atoms, which also will be repulsive. So these two are kind of in war between each other. And that you wouldn't be able to predict where the maximum density will lie at 4 degrees. It's more of an observation than anything. But it's interesting. So as the molecules slow down, then they're moving less quickly, and so they're going to kind of bump into each other less and be able to fall into this shape. But they still have to be able to move with enough kinetic energy to actually move. Otherwise, they're going to be frozen into one particular orientation, which is also the reason why water has so many different solid forms, because depending on how jumbled it is and how fast you freeze it, it could solidify into a variety of different ice forms. And so as you decrease the temperature relative to its peak, it's going to move less quickly, be able to get closer together due to these hydrogen bonding type interactions that can pull each other closer together, and the density drops. Whereas, if they pull each other closer together, the density should actually increase. And so as they slow down, it's actually not pulling closer together. It's actually this effect of them not moving fast enough to move around. And so you're stuck with, on average, the density dropping, because they can't they can't jumble around. They kind of got this shape that I've shown here. Whereas as you speed them up, they now can move around and reorient themselves to get into this hydrogen bonding shape to get themselves tighter together. So that's why it peaks at 4 degrees relative to 0. And then as they move faster and faster and faster, they then move further apart again, causing the density to drop again. Yeah. And so that's basically what's all written in here. I've just added in a couple little things. I've also made a small mistake there, but for the most part, I'd say that this solution is correct. And I've really just added in a couple additional points about what density is.